In this video, I wanted to show how to find the derivative of a radical function from first principles here. We'll just use the basic square root. You can extend this for other radicals like cube root or fourth root. The algebra gets a little bit uglier, but it is reasonable on an IB test question to ask you to do a square root from first principles. So here's our idea. We know what's going to happen. We know that if you have x, the square root of x, you can rewrite that as x to the 1/2. So we know the derivative, according to the power rule, is this, which is equivalent to 1/2 square root of x. And so I'm going to use the difference quotient and go through a few steps of algebra, and we'll get there. So we have the limit as h approaches 0 of x plus h square rooted, I guess I didn't need those parentheses, minus square root of x over h. And the key thing here is wishful thinking, noticing that we want to have two square roots of x on the denominator. And so in order to do that, I'm going to do multiply by square root of x plus h plus square root of x. And the reason I have a plus there is because when you do the limit as h goes to 0, I'll have 2 square root of x on the denominator. And if you do plus also on the top, this leads to some really nice cancellation. So what I'll do is multiply out the top. When I do the first times the first, the square roots cancel to be x plus h. Then I have square root of x plus h times square root of x. And I have a negative square root of x plus h times square root of x. And at the very end, I have minus x because the square roots cancel. All of that is divided by h, square root of x plus h plus square root of x. Oh, forgot to write the limit. The limit as h goes to 0. So there's some nice stuff that cancels now. Positive x and negative x cancels. Positive square root of x plus h times square root of x cancels with negative square root of x plus h times square root of x. And that leaves us with the limit as h approaches 0 of h divided by h square root of x plus h plus square root of x. H's cancel out very nicely, and we have 1 over the square root of x plus square root of x. I did the limit as h approaches 0 there, and then that just is 1 over 2 square root of x as desired. In the next video, I'll talk about how you handle rational functions, in other words, when x is part of a fraction. Thanks for watching.